Myself, Shankar, I am from AML Section 3. Today, my topic is about histograms of oriented gradients. There are two types. One is complete detailed seminar presentation, and the other is computer vision and image processing. The overview of HOG is like HOG is a feature descriptor used in object detection. And the mainly it captures the structure and shape of the objects using gradients. It was proposed by Navneet Dalal and Bill Tracks for present its detection. It is studied for like robust to illumination changes. It mainly focuses on edges and gradients, but not on colors. It works well with linear support vector machine. Historically, it is important before deep learning era. The basic idea of HOG is objects can be represented by edge directions. It is compute gradient orientation for each pixel, where it builds histogram for these directions inside small regions. It follows few steps. One is Step 1 Gradient computation, where it uses Sobel filters to compute Gx and Gy. Magnitude is equal to strength of edges. Orientation is equal to direction of edges. It mainly helps to identify shape boundary clearly. Sobel filters. Gx detects vertical changes, Gy detects horizontal changes. HOG uses both to find gradient direction. In step 2, the image is divided into cells. Cell size must contain 18 to 8 pixels. Each cell creates its own histogram. Histograms represent gradient descent distribution in that era. In step in step 3, it does orientation pinning. Usually, it does 9 bins from 0 degrees to 180 degrees, where each pixel votes for a bin based on gradient direction. Vote strength is equal to the gradient magnitude. Let us take an example for histogram voting. If a pixel gradient is 30 degrees, it votes in the 20 to 40 degrees bin. Weighted by magnitude gives shape information. In step 4, group cells into blocks. Blocks is must be 2 into 2 cells and 16 into 16 pixels. It should blocks must overlap by 50%, where it prevents suddenly lightning chain influence. Step 5 Block normalization. It is essential for illumination invariance. Normalization techniques L2 norm and L1 norm. Normalized blocks histograms improve accuracy. The last step is build final descriptor. In this where I have to concentrate on all blocked histograms, where it creates a long feature vector where it is more than 4000 values. It represents the complete shape structure of the object. Let us take an example for 16 into 128 window. It is common in precedent detection where it produces 105 blocks. Final descriptor is equal to the 4000 features. HOG plus support vector machine classifier, where HOG features fed into linear support vector machine. Support vector machine detects object presence extremely effectively for precedent detection. There are several applications for HOG. They are precedent detection, vehicle detection, CCTV surveillance, robotics navigation, gesture recognition, traffic monitoring systems. There are few limitations. There are few advantages of the HOG. One is easy to compute, no training needed for future extraction, performs well with rigid objects like humans. Advantages of HOG. It is easy to compute. There is no need of training for future extraction. It performs well with high rigid objects like humans. Robust to compute, illumination, and shadow. There are several limitations for HOG. It cannot handle rotation well. Very high dimensional feature. For example, like more than 4000. It can use deep learning CNN to outperform HOG. It is slow compared to modern detectors. HOG versus deep learning. CNN automatically learns features. HOG requires manual featuring engineering. Yet HOG is still useful in low power devices. Good for traditional CV projects and teaching. The final conclusion is HOG is a powerful classical feature descriptor. Extracts gradient based shape information. It is widely used in early object detector. It is important foundation for understanding modern CV. Thank you for this.